Well, welcome to part 6 of the ESTeem training series, where we're actually looking at part 2 of how to configure the radios for wireless Ethernet. What do they function as? What are the different modes of operation? How do we get a complex communication network like Ethernet communication to work over a wireless link? So what we were going to do first thing is kind of review one of the things that we looked at in the previous section, or part 1, which is which modes do the radios support and what is actually available to them as far as data transfer in each one of these modes. The first thing that we'll look at is this mode called the AP bridge. Really what we're talking about here, the easiest way to think of this, at least the way it works in my mind, if you are to take the radio that we have here on the left and you are to divide it right in half. What we're talking about here is how does the Ethernet interface relate to the wireless interface? Because what we're doing is we're really creating two different networks, the Ethernet network on one side and the wireless network on the other. So how do these different modes relate to each other? So in a bridge mode, what we're doing is we're bridging from the Ethernet to the wireless. In that case, all data is transferred across that link, both directions. There's absolutely no limitation to what kind of traffic. It works. It's very simple. It's a very simple configuration for it. The only downfall to it is that if you plug the radio into a very busy corporate network, all that data traffic will now require getting put across that network also. So that may not be the best solution. The next mode that we'll take a look at is the AP router mode. And the way that a router works is it identifies specific IP address ranges and will allow those addresses to pass. Anything that are not within that range immediately get blocked within the radio itself. So what that does is that now we can see all activity that is occurring on the network on the Ethernet side. The only thing that goes to the wireless side of that network are those addresses specifically allocated or designed within the network to be able to come across there. So you can isolate out the traffic specifically for those remote devices. Oops, sorry about that. The other mode that we want to talk about is what's called an AP masquerade mode. The best way to think of this is it works like a firewall. Communication can be requested from the wireless side into the wired side, but nothing from the wired network at all can push into it. It works very much the same way your home router does. The internet as a whole cannot push through your home router because its functions is pretty much the same way. What you're doing is you're consolidating the entire network on the inside of your router to one single IP address on the masquerade side or the data side. So what that does is that effectively cuts all communication coming into the wireless network, but the wireless network can actually request data from the wired network. Okay? Understanding how that works is going to be critical because when we start talking about the client modes or the mobile modes, we're going to use the same terminology again: bridge, router, masquerade. Again, the best way to think of this: bridge allows everything, router allows specific IP addresses within the range to go through, and the masquerade will only allow communication going one direction. It cannot be pushed through the wireless, it can only go into the wired system. All right. So when we're talking about the access point router mode within the radio, we're effectively turning the radio into a router itself. It's going to route the data between the wireless network and the wired network. There is more extensive network configuration required because now you have more than one single IP address you have to deal with. You're going to have one IP address on the Ethernet side, and you're going to have a second IP address on the wireless side. The way that those two function, or the way that those two route, is a network router is required somewhere within the system. And what that network router does is if the radio receives an address that is not for the network on the other side, it then goes to this router and says, okay, how do I get the communication to that point? It's resolving the communication link. If it is designed to go through the wireless link, it'll pass it. If it's not, then it'll push it off to the direction that it needs to go. The idea here, though, is there needs to be a router somewhere in the network, something that contains where the routing information is. That can be an existing router in the network. If that's the case, all you do is you point the radio at that router and it resolves the information. If that's not available, you can actually configure the ESTeem itself as a router to where you put in the fixed IP addresses into the radio, and as soon as it sees the address for that remote, it will actually figure out how to get it there. So again, the applications that where this is going to be used is generally larger plant networks, or if we need to segment the network apart so that only the communication for those remotes gets to that remote side. Let's take a look real quick when we're talking about IP addressing, because what I want to do is I want to make sure that everybody's got a good basic understanding of how the communication goes through. The first thing we need to understand is TCP/IP, the address that you generally will see listed here, like a 172.16.0.0. That address number by itself really doesn't mean anything. It's consistent really of two different elements, both the IP address and what's called the net mask. What it does is the net mask tells the computer what type of addressing or how the network, the IP address is broken down. The IP address really is broken into two parts, a network address and a host address, or the device address itself. Where this can be somewhat confusing is this is actually done at the bit level. So if you're looking at an address that we have here, like a standard, what's called an IP version 4 Class B address, which is the standard for all of the radios, it actually will start out 172.16. Since we are masking the first two digits within there, everything that starts out 172.16 is considered on the same network. The addresses on the other side of that, or which aren't being masked, which have a 0 and a 0, those are the addresses within this network. So this network that we create with a Class B addressing system can have up to 5,000, 52,000 addresses, because we've got 256 addresses and 256 addresses on these last two digits. So what's important to get out of this is when we start looking at a router, when we're talking about a different subnet, what we're identifying it by is something then is changed within these first two numbers. So if we have an address that's 172.17 instead of 16, that is considered a different subnet, or it's different network name. If you have an address that's a 172.16, let me get it up here, 6, and even though the top one says 37.5, if this one is 58.3 and it's using the same subnet mask, the first two digits are the same, so therefore they're in the same subnet. Okay. So what is different here is that if that device is trying to communicate out to an address that isn't on its own network, the device is programmed to communicate. In this case, it has the address of 172.16.37.5 and tries to talk to an address that's 172.17.37.5. That's on a different subnet, so it actually gets pushed out to what's called the gateway. Now, what that gateway address is that is essentially the third part of the IP address that says if it doesn't match where my address definition is, where do I go to find out where to get it to? That gateway address is identified. That is the address that you put within the radio to point at as we were speaking about on the previous slide, that's the point that's going to resolve it. That's the router address itself. Let me put up a couple examples here and see how this looks. Okay. There's a lot of addresses up here, so it can be a little bit confusing. But what I want to do is just show you the difference here. When we're talking about the programming from an AP router side, the wireless IP address, and here is the Ethernet IP address. You can see here that they're both using the same subnet, 255.255.0.0. So to make them on separate subnets, the something within these first two digits have to be different for them to be on a different subnet. So as you can see here, the wireless IP address is on the 16 address, the Ethernet address is on the 17 address, so therefore that's considered a separate subnet, so that would be correct for configuring a router. There is a lot more detail that goes into it, but this is a good starting point to understand that to be in a router mode, we have to have a different subnet from the wireless IP and the Ethernet IP, and this radio needs to point at someone within the network to say, if I see that address, where does it go to? Well, in this particular case, when it's set up as an access point router and the radio itself has the routing information in it, it essentially points, as you can see, at its own address to say, okay, I'm the router. And what it does is it then creates a static route. So a static route is written within the radio that says, if I see an address from 172.20, then that means that that information gets pushed out to this address. So it really is just resolving where do I find the addresses within the system. So as you can see here, if the radio is talking out to this other radio, which is also in a station router, which we'll come back to as far as how it's configured, but the devices that are connected to it start out 172.20. This then says, okay, if I see this address here, I am actually going to put it towards this radio, which is 172.162.22. And as you can see here, that's the radio it's connected to. So when you're setting up the access point router, station router, anything that deals with a router, you're making sure that all of the addresses within the system have a point to who they're communicating to. So when we get to the other modes of operation, it'll make a little bit more sense. Let's go ahead and start really with how do we configure the access point router. If you haven't done so, I would highly recommend to basically reviewing what we went through yesterday as far as the configuration on all the pages within the access point bridge. Because what you're going to find is that the access point router has many of the same exact pages that we go through. So just like we started yesterday, what we're going to do is we're going to start with our discovery utility. Now, what our discovery utility is designed to do is to find those locations or find the radios that it's physically connected to verify that the IP address matches the computer that's attached to it. So I'm going to press the discover. We see here that the radio that we currently have is currently set for AP bridge. We're going to reconfigure it for AP router. The difference here is that I know my computer starts out at 192.16 address with this net mask, so those two should talk without a problem. So what I can do is I can click on that, do a right mouse click, and press configure radio. Well, what this will do is put that IP address into the address line. So as you can see here on your screen, what we can do is simply type in the default username and password, which again is admin, A-D-M-I-N, for both username and password, all lowercase. When I press sign in, what we'll do is we'll be looking at the main page of the radio. Now, this is going to be a Horizon 5.8 gigahertz radio, and all of the radios that we have, the Horizon 900, the Horizon 2.4 gigahertz, the 5.8 gigahertz, and the Horizon 4.9 gigahertz, all have almost identical layouts, same modes of operation, same everything to them. The only difference between them is the frequency they operate in and the speed that they can transmit at. So with the 5.8 gigahertz, we're going to go up to setup. And as soon as we hit setup, we're going to take this out of the AP bridge mode and we're going to put it into AP router. Now, as soon as we select AP router, what it's going to do now is it's going to start asking us very similar to questions to what we did when we configured the AP bridge, but now we have to program two different sides of the radio, one for the Ethernet interface and one for the wireless interface. So now it's going to ask us, do we want DHCP on the Ethernet interface, so the one we're connected to? So again, we will have a fixed IP, so we're going to say no. And we don't really know at this point whether or not we need this to be the root bridge. We saw part 5 training. We went into how to configure a root bridge, how to configure the mesh type of network. So the root bridge is a critical part of that. What I have here on my desktop is I actually have 2 radios. What it will do is one of the 2 will become the root bridge in that wireless network, but because there's only 2 nodes, it doesn't matter who it is. So we can actually leave both of them at off if it's just a point-to-point. I'm going to go ahead and press the next button. Now what it's going to do is it's going to ask me to put in the information for the Ethernet IP. This is going to be half the configuration for the system. I'll keep it at the 172.16.8.169, the net mask. The only difference now is that I need to point this radio at itself to become the router, unless there is already a router established within the network. You'll always want to point the router at the Ethernet side, not the wireless side. What that will do is that will allow the radio to see what the communication is coming from both directions so that it routes it correctly. So in this case, all I need to do is type in there 172.16.8.169. So the radio is effectively pointing at its own address as the router. So when we configure the radio later and add the routing information to it, it will then be sent to the radio. The radio will internally look up where to go within the system and send it off to the correct destination. We then can press next. Now, again, it's going to ask us the same questions, but we're going to be talking about the wireless side of the network. Okay? We will have a fixed IP address in our network. We're not going to worry about which one's the root bridge for this particular system. As you can see, what it does is it automatically told us that we can now it automatically puts the default address at a different subnet. So if your address is 255.255, as far as the net mask, as you see here, it just automatically increased the digit the second digit by 1. So this one is the bridge IP address, so the wireless side is going to be 172.17.8.169 with a net mask of 255.255.00. So our Ethernet interface is 172.16. Our wireless interface is 172.17. The 2 are on separate subnets, so it will work. And as you can see here, the default IP route is again pointing at the Ethernet side of the system. The rest of the configuration is going to be identical to what we did during the AP bridge. The only difference really between the 2 radios as far as configuration is that first section where it's asking about the IP address. So we set the 2 radios to the same bandwidth. They have to be the same. The max distance, again, what that is the furthest distance that this specific radio is going to communicate within the network. What is the furthest one away? The next one is going to ask us for the channel that we're going to be operating on. Depending upon the radio that we are dealing with, this one is the 5.8 gigahertz, so it has 13 different channels. The 2.4 has 11 different channels. The 900 megahertz has 4 different channels. So the different radios may be a little bit different, but it's always going to ask you to put them on this or select a channel as the next one within the configuration screen. We just need to make sure they both match. Once we've completed that, we're going to be getting into now the access point side of the access point router. The SSID is the network name. The encryption type that we put in there depends upon, again, which encryption level we're going to do. If we're going to run to high throughput rates, it actually requires WPA encryption for both. It can be 128-bit or 256-bit, but it has to be a minimum of WPA encryption. If you've got older hardware or you don't want to run any encryption, you can put it at the standard rates. And if you put the standard rates in, what you can see is you can actually run that all the way down to none, WEP, which is wired equivalency privacy in both 64 and 128-bit, WPA, which is the precursor to WPA2, makes perfect sense, both in pre-shared key and enterprise mode. So what this can do is you can force it up to the upper rates, but if you have anything lower than WPA2, it has to be in that standard rate mode. For our purposes, we're going to be communicating to another radio, and this particular application of a point-to-point, we're not going to have any mobile clients coming into it at all, so we can just leave it at default at the high throughput rate. We go on to the next screen. We then select which level of encryption type do we want to have. WPA2 at 128-bit or WPA2 at 256. Pre-shared key versus enterprise. Again, pre-shared key, you enter in some information, the same at both sides, whether it be numbers, letter, any combination, but it has to be identical at both sides. That then generates a key at both sides, and then therefore they can come off and start communicating. Enterprise just takes it one step further. Instead of having the radio and an entry into that set what exactly is the encryption type, it actually goes off to a secondary server, what's called a radius server. And so depending upon which level you select is going to push you towards the next screen. Protected management frames are a next generation of for wireless clients. A lot of them will now be coming out and support protected management frames. Really what these are is these are the frames that are sent back and forth between the radio and the client device that tell it speed and who is it communicating to. And what this will do is the only really impact that you have within the system is the higher level of encryption that you put in there, the more impact it has on the overall throughput. The CCMP model for all of these that fall within WPA2 is fairly efficient. We don't see a tremendous amount of overhead to it. But as you can imagine, as we saw on the legacy rates, if you're not running any encryption as compared to a higher level encryption, the higher level of encryptions have a larger impact because they actually have a greater overhead. So there's going to be less data within there for each block of information. The next thing we can take a look at is hiding the beacon SSID. Well, everybody's seen this, whether they realize it or not, is when you go into an office building or a shopping center or a hotel, and the SSID of the available networks are out there. Well, you have the ability to hide those within the radio, turning them on or off. So by default, we leave it off, so it will beacon the SSID so that you can see it within your handheld device. The next thing it's going to ask us is what passphrase do we want to use? Again, we're not going to be using in our network any clients, so it does not matter really what our passphrase is. The next one is going to be the access control list. Well, this access control list is quite honestly just a simple MAC filter. You can put in there specifically which addresses you want by their MAC address you want this access point to allow or reject specific MAC addresses of the network. So even if you had a closed network, turning off the beacons, you can actually limit the clients that come into it by the device's address itself. It makes it incredibly difficult to spoof that and take over the network. Beyond the configuration that we had before, everything that we saw here was for the access point side of the system. Now, the next area that we configure is what's called the peer address. These are going to be the other fixed radios within the network. Now, this radio is configured as an access point router, but it can actually talk to another access point router, an access point bridge. It doesn't really matter. It just has to be another access point within the network. The client or the mobile clients do not get added into this setup. As a kind of a quick review, to add another radio, I'm going to want the radio I'm plugged into to communicate to a serial number that is 26070. So to do that, I just simply push the add button. When that page comes up, I can enter in the MAC address for this other radio, or I can just simply type in the serial number. Now the serial number starts out Z-26070. The radio will actually take that as a peer link. So if I press create peer, it will automatically strip that off. You can just simply put in the numbers also, will work just fine. But as you can see, it went and looked up what the wireless MAC address is, which ends in C59A, which matches what's on the back of this radio. So that is how we create the link to this particular remote. The radio ID is just simply a name. We're going to call this one the master side. And again, what this does is this allows the radio to be locked out from the discovery tools changing the configuration, pushing a change to it, pulling a change from it, or you also have the ability to turn off remote assistance. Each one of these just adds to the overall security of the system. So to finish this, all we do is we simply come over here and hit the button that says commit changes. Now, anytime that you change or write the information to the radio and commit the changes to those, it's about 45 seconds for the radio to reboot. So what we'll do then is we'll go ahead and jump back to the PowerPoint slide really fast. And from there, we will jump back to the radio and we'll see the changes that that has made to it. So what I'm going to do is we're going to go back to the original screen over here, which still has the diagram for the access point router shown on it. I'm now going to go down and bring back up our Discover utility. I'm going to go ahead and clear the list. It looks like that radio is almost done rebooting. As soon as it comes back up, what we can do is we'll just hit Discover again, and now it'll come up as a different mode of operation, but it will also show within there the changes that we made to the IP addressing for it. So if I hit Discover, and now once I press it, you'll see here that this is the address of the radio that I'm programming, which is 26069. These are the MAC addresses, and as you can see here now, the 172.16.8.169 shows up there as the router. It's now in AP router mode. So if we go back to the web page for that, we just press go to home. What this will do is this will take us back. Now we can see on here that we are in AP router mode, and we now have our wireless side is at 172.17.8.169, but the Ethernet side is 172.16.8.169. So what we've done is we've made everything that is required to make that router function. The only other thing that is required to this is to add the addresses for the remote. If you're going to make this radio a router itself, to add those addresses in, you simply go to the Advanced tab, go down to where it says Static IP Routes, hit Next, and within there, therefore, you can set up your address routing table to your remote locations. With help on that, you may actually have to get involved with the IT people, or please give us a call. We can help you sort through those. That's something just kind of beyond the scope of what we can do here in this this online training. So what we'll do is we're going to go ahead and continue on then to the next page, which is when we will take a look at the AP router. Let's take a look at the masquerade. Well, the access point masquerade is the configuration on it is identical to what we did for the AP router. The only difference between that is how the access point masquerade functions. So the AP router, now we saw that if we're talking about the difference between the Ethernet interface and the wireless interface, data coming into the Ethernet interface that matches what's required will go across the wireless. The AP Masquerade handles that a little bit different, because what happens is that the data that tries to push into the wireless network, when this is an AP Masquerade, immediately gets rejected. It is only one way. The difference here, though, is the devices that are connected on the wireless side, they can actually request data from the Ethernet side. That data will be passed just like it does on a home router, and the response to that will get back to who it is. But no initiation of communication can happen from the wired side into the wireless. Therefore, that's what creates the firewall. The devices beyond it can work and request information from the Ethernet world that will respond and get it across there, but nothing from the Ethernet world can push through into the wireless side. That is really the key difference when we're talking about the masquerade mode. So when we were talking about an access point masquerade mode, again, the radio functions just like we did from an access point side for the mobile clients. The configuration for it is absolutely identical to what we did during the access point router. It's going to ask us again for those two sides of the subnet. It's just the application of it is what is different. It's really used to isolate the wireless network from the wireless network. The wireless network from the wired network, excuse me. The applications for it would be network firewall requirements, to where you're going to get functionality similar to what you've got at your home DSL, cable, router, to where you can request information off the internet. No one from the internet should be able to push through and talk directly to your computer. Works the same way. So let's go ahead and take a look at what other modes of operation the radio can be configured for. We now have covered the AP bridge, AP router, and AP masquerade. Now, the opposite side of that is the radio can be configured as a mobile client. It functions in much the same way that your cell phone or a tablet or a laptop does inside of a Wi-Fi network. It is the end point. It is the client point. The difference is that it's designed so that it can automatically roam between multiple access points. So if you had a large plant floor you're communicating to, and you had a machine or a fork truck or something like this that needed to go around to this, instead of creating a link to each one of those, a direct link like we did when we created the peers, you can put the radio into a client mode, and it will link to the access point that has the highest signal strength. There are some changes to that, which we'll cover here in a couple slides when we're talking about how we roam between those. But what it will do is it's designed so it will automatically transfer from base node to base node. Because this base node, these fixed points, or these access point bridge router masquerade radios, they create effectively a wireless canopy that the mobile clients move within or go underneath of, much in the same way a cellular network is written, or excuse me, a cellular network is designed. You've got all of these cell towers out all over the place, and your cell phone hands off to whoever's the closest. We're essentially recreating that. The difference is that now, because we can set our modem as, or excuse me, our radio as a mobile client, we now have the ability to actually greatly extend the range, because now you're putting out a full power on both ends. You're putting out, say, for example, in the 2.4 gigahertz, 1 watt of power in both the client and 1 watt of power at the base. So the range on that can be a lot more than if, say, the client were only having, say, 25 milliwatts or 100 milliwatts, which is very common for, say, a handheld device. So we now realize that we can make the radio. What are the different modes that we can put it into? Well, there are 4 different client modes within the radio. There's what's called a station bridge. That is the newest mode of operation. And what it does is it's a very simple mode to deal with, because what it will do is anything that is connected to that remote or that mobile device will automatically transfer information back and forth into a bridge. It's going to look like effectively, it's going to look like a bridge link to the AP, but instead of having it listed as a peer, it actually will connect as a station. So it connects as a station, which is the bridging all the devices that are connected to it, or it can then move on to the next one and it bridges all those devices. And what I'm making reference to is, let's say, for example, we have a fork truck inside of a plant floor, and on that fork truck is a worker's terminal to where they type information to see where their loads that they're going to go pick up is. There could have a PLC on the fork truck that does everything from monitoring, position location, anti-collisions, and it can also have a camera so that you could see for maintenance where it's located or what it possibly ran into or had a problem with. All of those devices could be connected into a single radio configured as a mobile client, and the simplest method of communicating between them is the station bridge. Now, the only time as kind of a a subset of what we have available on the station bridge, you can also imagine we also may have a need for the radio acting as a router or a firewall. The only difference is it happens on the client side now. So you could have all of these devices, which we talked about, the camera, the PLC, the terminal. They may all want to be able to talk to each other and share information, but they may not want all that information to be put out onto the wireless world. If that's the case, you can configure that as a station router. So those devices, the only thing that goes across the wireless network is those that are specifically designed to do it. Same thing for the station masquerade mode. All the devices can talk to each other. They can request information into the wireless world, but nothing from the wireless world can get inside of that station. It's a very unique case, but the radio can be configured for any one of those. The only one that's any different, and the reason I leave it to last, is there's something also called an ether station. What this does is this really turns the radio so all of the normal functionality of it, as far as the bridging, routing, masquerade, it disappears, and it really looks like it is becoming the device it's connecting to. So if you hook it into a laptop computer, what it will do is the radio actually masks the MAC address of the laptop and becomes a wireless client for that laptop with a higher output power. It's a very simple. The only downfall to this is the fact that it can only support one connected device. We've used this in many different applications. The most common use for EtherStation was an applications that we did for public safety, to where the radio was configured as EtherStation mode. The officers had their own laptop, so they put it into the vehicle, plugged it into it. The radio recognized that, oh, hey, that's a connected device, and changed its MAC address to mask the connected device. There was no user input, no user configuration. It was a very simple and clean interface for it. So what these do is these allow the radio to function as a mobile device, but also allow you to control where you want the data to be put within the network. Do we want all the data to go across on the bridge, or do we want to route or put it into a firewall mode on the client side of the network? So let's go ahead now and jump back over to the radio that we are programming. And what we're going to do is let's go ahead and take a look at a couple client modes that we can put the radio into. So to do this, what I can do is I can just simply go back to where it said restore, and I'm going to restore the last committed changes, because what we had done is we had gone through the radio and made a few changes to it, but I don't remember where we were. So this, by setting it to the last committed changes, is as if we just logged into the radio. We're not going to pick up any saved data. So we're now going to go back to setup, And what we can now do is we're no longer going to be dealing with the first three anymore. We now have these four lower ones. Let's go ahead and take the most commonly used one, which is the station bridge. As a station bridge, the radio links into the network really based upon some very simple elements. What it's looking for is SSID, or the network name, and the encryption type. Those are the only two things that that radio needs to log into a network. So as you're going to see here, the configuration for it becomes much simpler. Do we want the radio to be DHCP? In other words, it's going to have a fixed IP, or is it going to be a DHCP client? It makes no sense being a DHCP server on the client end, so that's why we've cut that off. The next thing is it's going to ask us for the IP address. So we enter in the information, the 172.16.8.169. If this is going into an AP router, the default route would be, say, the wireless side of that AP router. If there's any questions on what those configurations need to be, we'll be happy to help you with that too. For our purposes, though, we're just going to leave it at a single IP address, keeping the same IP address we had from before. It's now going to ask us the critical elements of the radio side of it, the bandwidth, the distance. Now, as a mobile client, it is a little bit different in the fact that a mobile client actually scans all the available channels that it has. So you do not need to specify a specific frequency. The reason that they do this is as you're laying out this larger wireless canopy that's above the radio, you may have some of them on multiple channels so that they don't interfere with each other, so that the mobile devices can roam between it, but the actual access points do not interfere with each other. So the key to this now is, again, we need the SSID, the encryption type. As we looked at before, we can go everything from none all the way to 256 AES with enterprise mode and protected management frames. We just need to match the settings that were set in the access point side. That's the critical nature of this. So once we've done that, depending upon which level do we select, we may be putting in a passphrase, putting in information as far as the radio server for enterprise mode, or putting in different settings depending upon the actual encryption level we put in. So for our purposes, we'll just hit next. And as you can see here, it becomes very simplified because we no longer have to deal with peers, anything like that. The radio then can be just used as mobile. Okay? We can just call it the mobile, and we'll commit the changes to it. So as you can see, the configuration of the radio and how it is actually set up becomes much simpler from the mobile station side. Again, depending upon which mode you select, you may see different menuing systems come up there. But what we'll do now is let's go ahead and go back to our PowerPoint slides, because the next section that we want to cover is how do these radios move? Now, the way a typical wireless client functions, like your cell phone in Wi-Fi mode or a tablet or computer, what it really is designed to do is it will stay with whichever access point it connects to until the point it loses a signal, and then it finds the best one that's available to it. Well, the difficult portion of that is that if you create an overlapping coverage to where one access point can cover up to the point to where the other access point is, you lose a lot of the features to it. Another thing that happens is when we're in a mobile client, we've got such high output power that what would happen, we found this really when we did some early public safety applications, to where in the center of town we had a water tank. Everybody connected to that because it had the best signal, and even though we had access points across the city, it never lost communication with that center one, so it always did it, even whether or not it had the best signal strength or not. So what we had to do is we had to create what's called a custom roaming code. Now, what this custom roaming code does is it allows you to configure the radio to say, okay, at what point do we want to consider or looking or changing to a new access point? Because what that does is we create what's called a threshold within the radio. It's based upon the signal strength and the number of missed packets. The idea behind this is that we want that radio to stay with the access point it's connected to until the point it actually can find a better access point. So what we can do is we set a minimum signal strength to say, okay, you're going to stay, even if you find an access point with a better signal, you're going to stay with this access point until the signal strength meets a specific value. So that value by default is like a minus 80 dBm. So what happens is as soon as that access point that it's talking to drops below a minus 80, if there is another access point with a greater signal strength, then it will roam. If, for example, if you're in an indoor installation and your signal strength never really drops that low, you can move that up to say a minus 50 dBm. So then as the device moves as a client across the network, if it sees that the access point it's associated with or talking to drops below that minus 50 and there's another one out there, it will automatically associate with it. The purpose behind this is that you can fine tune how you want these mobile clients to move within the network. The idea behind this is you always want it to be connected. So what it will do is it actually goes through the verification of the network ID and security code before it even associates with the new access point. As soon as it associates with the new access point, at that point it disassociates itself with the old one. So there's always this handoff as it's going between the old to the new, so you're losing the minimal amount of data. That roaming client is something that is very adjustable, and we'll be happy to help lay that out to how the network is designed. It's a little, to go in all the fine detail would probably take the rest of the afternoon. So what we want to do now is let's go ahead and take a look at some of the different securities available within the radio. The difficult part is you can get buried in the acronyms. Once you get into security, the terminology that's used there can be very deep. The way to look at it is that this is actually all done essentially from the lowest level of security to the highest level of security, because that was generationally how it came out. WEP, which stands for Wired Equivalency Privacy, was the first generation of Wi-Fi mobile clients that came out, and it was in a 64-bit or 128-bit, which by itself is a fairly decent level of security. The tough part is that the way that it was implemented, it was done as a privacy measure, which is kind of in the name itself. It was really never done as a hardcore security mechanism. So they realized that there was a potential problem, and the governing body of this, back to the IEEE, said, listen, we need to do something with it. We can't have these clients out there that can potentially be broken into. What can we do? Well, the fix for it actually came out from a group called the Wi-Fi Protection Alliance, or the WPA. It used the same hardware that was available during WEP, but it used a different mechanism. And what it did is it took the header key and added to that a sequence number and the MAC address of the device that was connected to it. The idea was that with WPA, no keys ever repeated, which was potentially what the problem was in WEP. So WPA effectively solved the problem that was run into WEP. The only problem is that the IEEE had already taken off and was looking at the method of using what's called this AES, or this Advanced Encryption Standard. Now, because of that, WPA essentially acted as a stopgap until the entire full implementation, which is WPA2, Wi-Fi Protection Alliance version 2, allowed it to come out, which completely changed the mechanism, which in a lot of cases required a different processor in a lot of points. That's why they didn't want to do it early on. But it is an incredibly secure mechanism, to the point now to where the level of security that's available on the wired side is equal to, if not exceeding, the network security on the inside of it. So in a lot of cases, it's almost a little overkill really on the wireless side, but it's there. It's available to it. You also have within the mobile security not only the different levels, but again, we can hide the SSID, so you'd have to know what it is to be able to enter it, and disable those beacon probes. The last thing that we'll take a look at here is two different levels. The next one being it's very similar security levels, but because we're not everything that we mentioned here on this previous one, when we're talking about WEP, WPA, WPA2, all of those are pre-identified mechanisms that are laid out within the IEEE on the ways that a client communicates to an access point. The way that the radios communicate to each other on the peer link uses many of the same mechanisms, but we don't want to call it the same thing because it is proprietary. For example, WEPA 64 and 128, we didn't change the name. The TKIP, which is Temporal Key Integrity Protocol, is the mechanism that is used for WPA. Same thing when we're talking about CCMP, that is the mechanism used for WPA2, which is the functioning form of AES. So really, if we look at security, we have the same levels, WEP, TKIP, up to CCMP. The only difference is we don't want to call it the same because it's working on a proprietary link. The other level that we put in there is one of the simplest, but also one of the most difficult to overcome. It is what we call the access control list. And the access control list is simply a MAC filter. We put it within the radio to say these specific MAC addresses are going to be allowed within the network or denied. So if you're getting a bothersome, client that is taking your bandwidth, you can deny that specific address. You don't need to put in a list of everybody that does work. You can deny those that are causing problems. You can do this in a couple different ways. You can either do it through what's called a single address. You can put an address range, or we also have within the radio to set under the advanced section what we call a global list, which says we will only accept clients that are ESTeem clients, not any others. So we have a tremendous amount available to us as far as the security. The only difference is if you have an access control list, that would require for somebody to break into the network to effectively go in, physically steal one of the radios, gather its information, put that radio back, and now have that client effectively look like that radio. What we're talking about here is we have to have a physical compromise of the hardware to overcome this access control list. If someone can physically get to the radios in the network, the security of what's on there is the least of the concerns for it. So what we've gone over on this particular type or this particular series is a continuation of what we have available to us as far as Ethernet communication. We concentrated primarily on part one. We concentrated on the access point bridge and how we do a basic configuration of the radio. On this one, we concentrated on the router side and the firewall, which is known as the masquerade, and what is available to us in the client modes. So where we're going to continue on in the next section is we're going to take a look at, in much more detail, the advanced features of the radio. What are the things that have to be done within the advanced settings? So I want to thank everybody for their time today and have a great day.